And then in part B, it is asking for odds for this probability. So since, remember, in odds, we need to figure out NE divided by NE prime. So NE, we already figured that out, 190, and NE prime would be just 1000 minus 190, because it's all the remaining cases. So then the odds would be just, the odds for this event would be just NE divided by NE prime, which is actually it is asking that as a fraction, so that would be just 810 divided by, 190 divided by 810, and you can take out the 0, so it'll be 19 over 81. And then in part B, the question is, the sum is even or exactly divisible by 3. So even sum divisible by 3. So I'm changing these. So the even sums, so looking at the even sums, so that's 2, which is 10, plus, so the even sums would be 2, 4, 6, 8, 10, and 12. So that's 10 plus 50 is 60, plus 110 is 170, plus 170, that's 340, plus 120, that's 460, plus 70, which is 530. So even sum is 530. Divisible by 3 is, that's 3, 6, 9, and 12, so which is 30 plus 110, that makes 140, plus 9, another 140, 280, plus 70, that makes 350. But notice there's an intersection here. There's an intersection because some of these even sums are also divisible by 3, so we're counting them twice, which is not right. So we gotta figure out which ones are even and divisible by 3. So that will be, so look at all the even ones and see which ones are divisible by 3. 2 is not, 4 is not, 6 is. So basically 6, 110, 8 is not, 10 is not, but 12 is. So 6 and 12, the sum 6 and 12 are both even and divisible by 3. So those are already counted in both of these. So that's why we need to subtract that from NE. So that's 110 plus 70, which makes 180. So then NE would be even sum plus divisible by 3 minus their intersection. So NE is 700. So that's why the probability is 0.7, because it's 700 divided by 1000. That makes 0.7. And E prime is 300, because NE and NE prime should add up to the whole sample space. So the odds here would be then, so remember they're asking that as a fraction. So even though 2.33 is right, as a fraction it's 700 divided by 300, which is taking out the zeros. That would be 7 over 3. So number 8 is the conditional probability question might seem complicated, and some of them are, but some of them are really simple. So in this case, it is saying events A, B, C are mutually exclusive, and also D and E are. So A, B, C cannot happen together, and D and E cannot happen together. But A can happen together with D and E, and same thing as B can happen together with D and E. And this table really tells you, for example, this 0.10 is the probability of A and E happening together. And for example, this 0.20 is the probability of C and E happening together. And look at the totals column. So this, for example, 0.40 is the probability of E happening just by itself. and this 0.20 is the probability of B happening just by itself. So in this conditional probability, the formula is given. So P A, the probability of A, given that D is also happening, it's the probability of A and D happening together, which is A and D happening together is 0.30 from this table. So 0.30 goes on top here. And then we divide this by the probability of D just by itself. So probability of D happening is, look at the totals column across from D, so that's 0.60. So then this would be 0.30 A and D together divided by 0.60, just the probability of D. So 0.30 divided by 0.60 is 0.50. So you can actually check that from here. 0.3 divided by 0.6, so that's 0.5. Okay, number 9, we're getting to the end. So number 9 is a typical deck of cards question. So in part A, it is asking, when you draw 2 cards without replacement, what is the probability that the first card is a spade and the second one is a club? So look at this setting here in the Excel. So first of all, in the total deck, there are 52 cards. How many of them are spades? 13. And how many of them are clubs? 13 again. So the first card being, so this is without replacement. So without replacement. So the first card being, and then we're going to do with replacement. So that we want the first card to be spade. So that is obviously number of spades divided by the total cards in the deck. So that's 13 divided by 52, which is 0.25. So now we're drawing the second card and we pull the spade and we're not replacing that. So for the second card, we want that to be a club, so there are 13 choices, again, because there are 13 clubs. And this time we divide this by not 52, but by 51. So I'll write that manually, because we already pulled a card, and now there are 51 total cards left in the deck. So that's the probability of pulling a spade, and this is the probability of pulling a club. And since we're pulling 2 cards and we want that probability of these 2 happening together, that's going to be, we just multiply them, right? So multiply the probability of first card and the second card. So that's going to be this number, and that needs to be rounded to 4 decimal places. So you just put 0.0637, and that goes on top here. And then in part B, it's the same thing, but this time we are replacing the card. So you pull the first card and then you put it back in. So the probability of the first card being spade would be the same, because there are 13 spades pulled from 52 cards. Sorry, I put, wait a second. Okay, so again, it's number of spades divided by total deck. So that's 0.25, same thing. And then the second card, we want it to be a club. Again, there are 13 clubs out of how many cards? It's still 52, because this is with replacement. You put the first card back in, so there are still a total of 52 cards in the deck. So again, these 2 are the same, and these 2 happening together is, we just multiply them, and that's going to be 0.0625 that goes here. So that's number 9. And then the last question here, I think this is the last. Yes, number 10. So in part A, we're drawing 2 balls. And again, here's the setup. There are 5 red balls, 2 white balls, so that makes total 7 balls. So in the first scenario, we're pulling 2 balls with replacement. So you pull the first ball and then you put it back and then pull the second ball. So here's the trick here. The question is, find the probability that at least one ball was red. So that means it's okay if you pull one red, one white, and it's okay if you pull both of them red, because it says at least one. So calculating one red, one white, and then both red, and then adding them up, that's just too much work. So instead, what we're going to do is we're going to find the probability that both balls are white, and then we're going to subtract that from 1. So probability of pulling at least one red is the same as 1 minus probability of both of them being white. So here's the probability that both of them are white. The first ball would be 2 over 7, so 2 divided by 7. And since we put it back, the second ball being white would be still 2 divided by 7. So we multiply those, and that makes 4 divided by 49. And then, so that's the probability of both of them being white. And then we subtract that from 1 to find that at least one is red. And 1 minus 4 over 49 is 45 over 49. So that's the answer to A. And then for B, it's the same problem, but this time without replacement. So you pull the first ball and you put it aside. You don't put it back into the bag. So again, the same thing. We're going to figure out the probability of both of the drawn balls being white. So the first ball would be 2 over 7, same thing as here. But the second ball being white, so you pull the white, and now there's only one white ball left, and there's a total of 6 balls left. There's still 5 red and 1 white, so that's 1 out of 6. The second ball being white would be 1 over 6. The first one was 2 over 7, so when you multiply them, that makes 2 over 42, and you just simplify that, that's 1 over 29. So again, we subtract from 1 to figure out the desired probability. So 1 minus 1 over 21 is 20 over 21. So that's part B. All right. Have a good weekend, everyone. I hope this recording helps you with your homework performance. And as I said in the beginning, you're going to get the exact type of questions, but they're not going to be the exact questions. The numbers are going to be different, and the order is going to be different. So I think you should watch these videos first, and then start your understand the solutions here, and then start your quiz. And during your quiz, you can maybe refer back to these solutions, and hopefully that'll help you with your quiz performance. So I'll try to do these videos every week from now on. Thank you.